Welcome to my algebra class. We're on chapter 10, section 8, and we're going to be working with systems of linear inequalities. In order to graph a system of linear inequalities, we need to change each inequality in the slope-intercept form for the first boundary equation. We do it for the second one. We graph the boundary equation and shade correctly, and we do the same thing for the second inequality and shade it correctly. When we're done, we have a region that has a double shaded area, and that is the solution set to the system. So if we pick any ordered pairs from that, it would solve both of them. So here we have a system of inequalities, and we're going to solve this one for y. So that means we move the x over, we'll add x so it becomes positive, and we add the 3. And we have less than or equal to. So our boundary equation is y equals x plus 3. Our intercept is 0, 3, and our slope is 1, up 1, right 1. So we graph that. Second point, 0, up 1, right 1. And it's a solid line. And it says less than or equal to, so we would shade below. The second inequality, we have to solve it for y. So we're going to subtract 2x from both sides. So we get 3y is greater than negative 2x minus 6. Divide each part by 3. So we get y is greater than negative 2/3 x minus 2. So our intercept is 0, negative 2, and our slope is negative 2/3 down to right 3. So plotting that point, 0, negative 2, and then we go down to right 3. That would be here. And it said greater than, so that would be a dashed line. And it said greater than, so that would be all the ordered pairs above. And then we find the part that's the double hatched area, so it'd be right in here, and you could actually even shade that to make sure you see it. So if I pick any ordered pair from that region, let's just pick this one right here. This would be the ordered pair 3, 0. If I put it in over here, 0 minus 3 minus 3, that'd be negative 6 is less than 0. That works. And over here, that would be 2 times 3 plus 3 times 0. It has to be greater than negative 6. So I get 6 is greater than negative 6, so it works. We're ready to do the assignment, so you need to turn to page 496, and it's written 1 to 12. And the directions say graph each pair of inequalities and indicate the solution system by cross-hatching or shading. So problem number 2, we have y is less than or equal to 5, and x is greater than or equal to 1. Boundary equation, y equals 5, x equals 1. So graphing, make a coordinate plane. And y equals 5 is a horizontal line going through 0, 5. And less than or equal to would be a solid line. And it said less than or equal to, so it would be shaded below. X equals 1 is a vertical line, and it would go through where x is, we could find the point 0, x is 1, 0, and it's a vertical line, and it's greater than or equal to, so that would be a solid line. And it says greater than or equal to 1, so that would be to the right. So our double hatched area would be right in here. And it would also include the lines, solid lines. And that's our solution to that one. Problem number, and you, as I said, you could pick a point anywhere in this area and check it. Problem number 4, we have y is less than -4 and x is greater than 4. So our boundary equations would be y equals -4 and x equals 4. Graphing. Y equals -4 is a horizontal line going through 0, -4. So, and it's going to be dashed. And it says less than, so we're going to shade below. X equals 4 is a vertical line, and it will go through 4, 0. And it is also dashed. And it is greater than 4, so we would be shading to the right. So the double crossed or double hatched area would be right in here. Realize it extends to infinity. So you could pick a point in that area and check it. Number 6. Whoops. Number 6. Our problem is y is greater than 3x, and the other part of the system, x is less than 1. So our boundary equation would be y equals 3x and x equals 1. Here the intercept is 0, 0, and our slope is 3, up 3, right 1. And this is a vertical line going through 1, 0. So graphing that, plot a point at 0, 0. Use your slope, up 3, right 1, and it's a dashed line. And it says greater than 3x, so we're going to shade above. X equals 1 is a vertical line where x is 1, 0. And it is a dashed line also. And it says less than, so that would be shaded to the left. So the crosshatch area would be right along this, and then shaded in here. Problem number 8. Says x is greater than -2 and y is less than or equal to 2x plus 7. Our boundary equation is x equals -2 vertical line. Boundary equation here is y equals 2x plus 7. So our intercept is 0, 7, and our slope is 2, up 2, right 1. So the first one, we put a point at -2, 0, and it's going to be a dashed line since it says greater than. And it's going to be shaded to the right because the x values to the right are greater than -2. So this is going to the right. Second equation, put a point at x is, on the y-axis 0, 7. So 1, 2, 3, 4, 5, 6, 7. And the slope is up to right 1, up to right 1. And it's going to be a solid line. And it says less than, so we're going to shade below. So our area that's crosshatched would be right along here, down here. So any ordered pair in this section here would solve both inequalities. Problem number 10. We have y is less than 4x plus 4, and y is greater than negative 4x plus 4. Boundary equation y equals 4x plus 4, so our intercept would be 0, 4, and our slope would be 4, or up 4, right 1. Boundary equation here is y equals negative 4x plus 4. Our intercept would be 0, 4, and our slope would be negative 4, down 4, right 1. So graphing that, so we plot a point at 0, 4, and the slope is 4, so we go up 4, 1, 2, 3, 4, right 1, put a second point, and the inequality was less than, so we need a dashed line. And it said it was shaded, it says less than, so we're going to shade below, or put lines below. And the second inequality, our intercept is still at 0, 4, but this time the slope is negative 4, so we go down 4, right 1. And our inequality was greater than, so again a dashed line. And that said greater than, so that was shaded above. So our area that's crosshatched, or where all the solutions are right along here. So any of those ordered pairs would work. And the last problem, number 12. We have y is less than 5x plus 3, and y is greater than 5 minus 5x. Boundary equation is y equals 5x plus 3, so our intercept is 0, 3. Our slope is 5, or up 5, right 1. This one, turn it around, the boundary equation is negative 5x plus 5. Move that 5x to the front, so it's slope-intercept form. Our intercept is 0, 5, and our slope is negative 5, so down 5, right 1. Make your coordinate plane. And the first equation, the intercept was 0, 3. The slope was 5, so up 5. Right 1. So our second point's about there. And it was less than, so it's a dashed line. And it was shaded, it said less than shaded, it would have to be shaded below. So, and the second inequality, the intercept was 0, 5. And the slope was negative 5, so down 5, 1, 2, 3, 4, 5, right 1. And it was greater than, so it's a dashed line. I think I moved. those out. So our intercept was 0, 5. I connected the wrong part there. So 0 is going right this way. And then it said it was shaded. It says greater than, so that would have to be shaded above. So the crosshatch area would be right along that dashed line and that one, and then everything here. Okay, that concludes the evens. Be sure and check the back of the book for the answers to the book for the answers.